Hi guys, welcome to today's video. This is 2019 paper 2, question 1 on probability. It also involves permutations and there's some tricky wording in there, so it's a good practice with understand the wording in these type of questions. So let's get into the video. Okay, so here's our question. We're told the class consists of 12 boys and 8 girls, and 2 students are selected at random from the class. We're asked to find what the probability is that the 2 students selected will be a boy and a girl in any order. So the key phrase here is that we're allowed any order. So because we're only doing 2 selections, there's going to be 2 different orders. We're going to have the probability that a boy is selected and then a girl, and the probability that a girl is selected and then a boy. So with that in mind, first of all, the probability that a boy is selected is just going to be 12 out of 20 because we've got 12 boys in a class of 20 in total. And now we're going to multiply this by the probability that after one student has been removed, one of the remaining students that is selected is going to be a girl. So that's just going to be 8 over 19 because we have 8 girls and 19 remaining students, given that the first boy was removed. So now applying the same logic to the second possible outcome, the probability that a girl is selected first is just going to be 8 out of 20, and multiplied by the probability that a boy is selected second, which is 12 out of 19. Again, because we've already removed one girl from the class. So all that's left to do now is simplify these 2 probabilities and then add them together. So when we put 12 over 20 multiplied by 8 over 19 on the calculator, we are going to get 24 over 95. And now putting 8 over 20 times 12 over 19 on the calculator, we are actually just going to get the same thing, 24 over 95. And this is kind of obvious if you look at the fact that the top numbers and the bottom numbers are both the same, just multiplied in different orders. So the total probability, which we're just going to call P, is equal to 24 over 95 plus 24 over 95, which is 48 over 95. So that's our final answer, and there's no reason to really convert this into a decimal, although you can if you want to. So that's A part 1, and that's worth 10 marks. So next we're told that 4 students are selected one at a time at random from the class. What is the probability that the first 3 selected will be boys and the 4th will be a girl? So this is once again just a straightforward permutation. So the probability that the first student selected is a boy, which we're just going to call 1b, is equal to 12 over 20. Because as we know from part A that there is 12 boys in the class of 20 in total. The probability that the second selection is going to be a boy is just 11 over 19 because we reduced the number of boys and the total number of people in the class by 1. The probability that the third is a boy is 10 over 18 using the same logic once again. And the chance that the fourth is a girl is just going to be 8 over 17 because we know that there's 8 girls in the class because we haven't removed any, and we've also reduced the total number of students in the class down to 17 at this point. So now to get P, the probability that we're looking for, we're just going to multiply all these things by each other because these are successive events, and this will just simplify to 88 over 969 if you just put that in on your calculator. So that's our final answer, and that is worth 10 marks. So now in part B we've got an examination with 2 sections. Section A contains 7 questions, section B contains 8 questions, and we're told in section A you must answer question 1 as well as 3 other questions, and from section B you must answer any 4 questions. We're asked to find how many different combinations of questions can maybe answered if a candidate follows that instruction. Okay, so it's pretty clear here that we can break this down into 2 separate choices, one during section A and the other during section B. But because in section A, one of the questions we must answer, that effectively removes that from consideration because it's mandatory. So therefore we're going to take away one of our choices and one of our total questions because that's one less thing we can add to the combination. So we have just 1 times whatever is left to choose, which is 3 from 6. So 6 choose 3, and all 6 choose 3 is just how many possible ways there are to arrange 6 things if you were to choose any 3 from that 6. So that just about covers section A. And section B is actually much more straightforward because we know that there are 8 questions and we're just told we can answer any 4 questions. So then it becomes clear that we're just picking 4 out of 8, so any 4 from 8 possibilities, which is of course A choose 4. So now we have the number of combinations for A and for B. So to find the total number of combinations in the entire paper, we are just going to multiply the number of combinations in A by the number of combinations in B. So we have 6, and shift choose, which is the NCR button, 3, which is 20, times A choose 4, and our final answer is 1400. So that's actually the number of combinations of questions that is possible to answer in this exam paper. It seems really high, given that there was only 15 questions in total and 1 that has to be answered anyways, but usually combinations do end up being really high numbers, so it seems quite right in that regard. So that is it for part B, and that is worth 5 marks, and that's actually it for today's question. I hope you enjoyed the video. If you did, there's going to be other similar videos in the description, as well as some other helpful resources, and I'll see you next time.